Okay, yesterday we started with the process of signal design, okay, and we went through the steps. Okay, so there are three main steps for designing the signal. We start with the phasing plan, and then we start calculating the signal timings, and then the last one is pedestrian check. From these phases, we have just discussed the first one, which was how to develop the phasing plan. Okay, and after you develop the phasing plan, you can show it with one of these diagrams, a ring diagram or a phase diagram. So today we will be moving towards the second step, which is the calculation of signal timing. Okay. From the signal timing, the first thing we calculate is yellow and all red time. Okay, and this slide shows you what else do we call the yellow time. We call it change interval. Okay, and all red time is also called as clearance. Okay, to calculate yellow time, we use this equation. Okay, you can see we are not using any traffic data here. No volume, no flow rate. Okay. We are using time. Which time? Perception reaction time. Okay, perception reaction time. Do you remember anywhere else you have used perception reaction time? For calculating what?
I think for the.
What did you calculate?
Stop size distance.
Yes. Okay. So perception reaction time is used for calculating the side distance. Okay, and it's the same thing. Okay, it's the same perception reaction time. Do you remember the value? Anyone remembers the value? 1.47. No, it's not. Okay, but for signals, it's 1 second. Okay, for signals it is for signals it is 1 second. Okay, so T will be 1 second. Okay. The next thing we have is at S85, which means 85th percentile speed. How to get the 85th percentile speed? We discussed in the spot speed data topic. Okay. So you have to draw the curve and find out the speed from the frequency distribution curve. Okay. But if you don't have the data or you don't have the curve, then you can use this shortcut to find out the 85th percentile speed, which is the mean value plus 5. Simple? Okay. A is deceleration of the car. So you are coming to the signal, decelerating, right? Deceleration of the car. G is the gradient. Okay, gradient of the road. Clear? The equation to calculate yellow time. Everything is clear? Moving on, if you are calculating all red time, we have three possible options. Three different options. And they depend upon how many pedestrians are crossing. Okay, these options depend upon how many pedestrians are crossing. If there are no pedestrians crossing, you will use this equation. If there are many pedestrians crossing, you will use this equation. If there are, somewhere in the middle, okay, then we will use this function. Okay, in all of them, we are using two common things, S15 and L. S15 means 15th percentile speed. S15 is what? 15th percentile speed. And how do we get the percentile? You have to draw the curve. Okay, if you don't have the data, you cannot draw the curve, then the shortcut is this one. Okay, mean minus 5. Clear? The other common feature is L. L is the length of the car. L is the length of the car. A normal car is around 18 to 20 feet. A normal car is around 18 to 20 feet. Okay. Then we have two values here, P and W. In some equations you will see P, and some of them you will see What are these values? You see the dotted lines in the figure? They are the stop lines. So you see stop line on both sides, right? Okay. Now what is W? From what to what? What is this? What is this?
Okay.
Huh?
Okay.
Stop line, not walk line. Okay. Stop line, okay? So W is from stop line to
Another stop line.
another stop line. Got it? This is the walkway. This is the pedestrian crosswalk. This one. The two solid lines. Okay? So P is from what? From the stop line to what is this now?
Pedestrian.
The crosswalk.
Crosswalk.
Okay? So W is from stop line to stop line. P is from stop line to crosswalk. Clear? Okay. So, like I said, you can use this equation, this one, depending on how many pedestrians you have. If you are going to use this one, this is a function. You can see max is a function. Okay. So you have to calculate two values. Okay. And out of these two, you will pick which one? Clear? Okay. Let us do an example. The data is given here. Okay, the speed and everything, the average speed and everything. They are asking us to calculate the yellow time and the off red time. Okay. Now, if I look at the equation, let me pick the equation. I take this one. Okay, if I want to calculate yellow time, is there anything missing here? Yes, for the yellow time. Anything missing? Do I have everything in the, given in the question?
Yes.
Yes? Yes?
85.
What about the speed? Yes?
85%.
85 percentile speed. This is speed is not 85th percentile. This is average. Okay? 85th percentile speed will be average plus 5. Okay, now give me yellow time.
Doctor, for the 15th percentile, minus 5.
Minus.
So what is the value of
Value of what?
A is
Yes,
10,
the
right?
deceleration rate, 10, yes.
4.2?
Okay, for the all red time, now look at the data. What did they say about pedestrians? What information is given about the pedestrians?
We have distance from stop.
No, pedestrians.
Some
Some pedestrians. Okay, first of all, I need to select, right? I need to select the condition. Okay, so some pedestrian means the last one. Okay, I have this condition, the last one. Okay. I'm going to use this one only. Okay, now tell me, do we have everything for using this function? Do I have everything available to use this function?
We have the P, we have the W. The only notes are the S15.
S15. Okay, so S15 was what?
So 35 minus 5.
35 minus 5. Okay, so give me the two. Now you have to calculate two values, right? Use the function, you have to calculate two values. Okay. Now look at, you said W and L are here, right? Okay, which one of them is W, which one of them is P?
P is 48.
P is 48, why? P was for the crosswalk. P was for the crosswalk. So this is your P value. Okay? And this is W. Got it? Okay. So give me the two values. So 1.6. Mm-hmm. 1.36, so 1.4, right? Now the function says take the maximum, right? The function says take the maximum. So I will use this one. Okay, so my all right time is 1.6. Clear? Any questions? Okay. Next we move on to is the calculation of loss time. Okay, we have discussed it earlier as well, and I discussed how to calculate it, how to get it. Here we will just discuss the values which they are given. Okay, so every phase of the signal has two loss times. One is the startup, the other one is clearance. One is startup, other one is clearance. Okay, startup means the signal has become green. Okay, and vehicles are going slowly. When it does become green, so we have some loss time. Okay, how to get it? Go back to the previous lecture, you will see. We can do a head rate study to find out the startup loss time. Clearance loss time. Another one is clearance loss time. We calculated sometime in the previous example, right? Which one of them is clearance? One of them is clearance. Which one? AR, right? All red. Okay, another name for all red is clearance. Okay, why is it clearance? Because nobody is entering. Only the vehicles which are in the intersection, they are just moving, they are just passing. That's why we call it clearance. Okay. So our assumption is what? When the signal is all red, this is clearance. Okay. This is our assumption up till now. Okay. Clear? What they are saying is something else. First of all, for startup loss time, they did the study. We have two loss times, right? Startup and clearance. They are talking about startup now. Okay, how to get the value? I already explained in the previous topic. So, they did that study. Okay, I did not teach them, but they did anyways. Okay, so they did that study. In that study, they found our startup loss time is 2 seconds.
Doctor, Bahrain is 10 seconds.
Minus
no, seriously, doctor.
It's minus 10 seconds. People are so smart, they see the vehicle from the other side is slowing down. That means their signal is about to become red.
Yeah, they wait for it to become red.
Won't wait for it, they don't wait. Start hearing pam, 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 pam. What is this? Okay. So they did their study, they found that for them startup loss time is 2 seconds. Okay, you can do our own study using the headway and find out our own loss time. Startup loss time, done. We know how to do it and we know the value which we can use. Okay, worst case scenario. Now, the other one is clearance loss time. We said clearance up to now, according to us, clearance means all red. Because all signals are red, that's loss time. All signals are red, it's loss time. Vehicles which are already entered, they are this crossed. Okay. So, but what actually happens? What is more practical is if you see the signal is yellow and you are far from the signal. Okay. What would you think in your mind? That it's about to become red. Right? It's about to become red, and I am very far. So I should prepare to do what? Okay, so you start to brake. Okay. You decide I will brake, right? So you will decelerate now. Your foot is on the brake. Okay, and it may happen, and according to that, it does happen that usually people who are at the back of the queue, they pre-decide that we will brake. Okay, so they make a fool of themselves. They come to the signal because they decided, they stop. And the signal is still yellow. Okay. So what happened now? Their clearance loss time is not all red. Their clearance loss time started from yellow, right? Because they did not enter in yellow. So the actual practical clearance time is all red, obviously, and part of yellow as well. Part of yellow as well. So again, they did their own study. And they found that vehicles which are arriving after 2 seconds of yellow, they think that we don't have enough time. Okay, vehicles which are arriving after 2 seconds of yellow, they think we don't have enough time, we should stop. And they stop. Okay, if you go back to the previous example, our yellow was 4.2 seconds. Okay, our yellow was 4.2 seconds. Okay. You are allowed to enter in 4.2 seconds, right? But practically, if you are too far, you think that I should stop. Okay. So any vehicle which arrives within 2 seconds of this time, they are prepared to go. Any vehicle which arrives after 2 seconds, they are prepared to stop. Okay. So because of these vehicles, the clearance loss time is not actually this. It's actually 2 seconds after yellow. Okay, 2 seconds after yellow. So my total time of yellow and all red is how much? 5.7. Out of this, 2 seconds of yellow, people decide to go. So 5.7 seconds, I will subtract 2. Got it? Okay. Those 2 seconds in which people are actually going. The remaining is what? Lost time. Got it? Okay. So the actual clearance loss time is not 1.5. Actual clearance loss time is 3.7 seconds. From where are we getting the extra 2.2 seconds? From yellow. Clear? Okay. So the startup loss time, they gave me a recommended value 2 seconds. Okay. Clearance loss time, I will calculate like this. Total loss time, this plus this. Okay. This one. Okay. The startup value and whatever you get from here. Clear? So the first 2 seconds of yellow are used, the others are part of clearance. Okay. The next step is to find out the critical lane volumes. Okay. Now which one is the critical lane? If you have 3 lanes in front of you, you have to design a signal. Which one you pick for as a critical lane?
Left one.
Why the left one? Your answer could be correct, but the reason?
It's the fastest lane, maybe.
The left one is the fastest lane. Is it yours or mine? Mine, right? People are calling, nobody's calling. Yes. The left hand side lane, because the fastest lane. Yes, anybody else? How do you pick a lane for your signal design? How do you pick a lane for signal design? The left lane is going where?
Straight?
The left hand straight. It's a signal.
Oh, left.
The left hand going left, right?
Yeah.
Okay. So the answer is correct. You should pick the left lane, not because it's the fastest lane. It is what? If people are turning left, this becomes what? The fastest or the slowest?
Slowest.
Slowest. Okay. Clear? So we pick the critical lane based on time. We pick the critical lane based on time. Okay. The one which needs more time. Okay. So if I have, for example, 1000 vehicles here turning left and 1000 vehicles here going straight. Okay. Are they equal? Will they take same amount of time? I cannot compare them, right? I cannot compare 1000 left with 1000 straight.
That will take more time.
Okay. Then, but my problem is, how do I compare between them? I have 2 lanes or 3 lanes and everybody is going in different directions. Okay. So should I pick this one or this one or this one? I have 3 numbers. How can I compare between 3 numbers and pick one? They should be in the same units, right? They should be in the same units. Okay. Those units are called as through vehicle units. You need to convert if you want to compare between vehicles which are going in different directions. You have to convert all of them into through vehicle units, TVU. All vehicles from different directions must be converted to through vehicle units. Okay? Clear? So that we can, now they are in the same units. After converting, they are in the same units. I can compare. 1000 here, 1000 here. This is 1000, this is 1200, I will take 1200. Okay? Because now they are in the same units. Okay? Why we call them through vehicle units? Through means straight. Through means straight. Okay? So I am converting what? Turning into straight. Straight is already straight. Okay? So everything into straight units. Clear? Okay? So you can only find out which lane is critical after you have converted the movements into this unit. Then you can compare and you can pick, okay, this one is higher, I will pick this one. Got it? Clear? Okay. How do we do the conversion? You have to multiply with some factors. Okay. How do I convert left turning to through vehicle units? Multiply with the factor of left turning. How do you convert right turning into through vehicle? Multiply with the factor of right turning. Got it? Okay. So there are 2 tables, one for left turning, one for right turning. Okay, and you can see the factors. If you are using the factor for left turning, you see the table. They are asking for opposing volume and opposing lanes. Okay. Now which one is opposing? Okay, if I am taking left hand like this, okay, is this left? Yeah, okay, my opposing is this one. Okay, for this left, opposing is, they're straight from the other side. Okay, this one has no problem with me. Got it? This left turn has no problem with me. So my opposing is which one? The top one. Clear? So when they say opposing volume, they are asking for this volume.
Doctor, the opposing is not coming straight, right?
Coming straight, yes. So left turn cannot oppose me, right? I am going in this direction and you are going in this direction. I don't have any problem with you. Got it? Okay. So they are asking for the top volume and how many lanes for that volume. Got it? Clear? Okay. And for the right turning, you must know the pedestrian. How many pedestrians are crossing? No opposing volume, only pedestrians. Clear? Now in this table, you can see the factors are given according to opposing volume and lanes, and then there is a factor which is given at the end. okay, which is for protected. So all these factors are for permitted movements. This one is for protected movement. This one is our case. This is our case. Okay. Protected means what? If the other signal is green, if the other signal is green, can I make the left turn? No, right? Because the other signal is green. What if there is nobody coming from the other side? Can I make the left turn? No. Because my left turn is connected with the signal. Okay? Yeah, I can make, but that will be against the law, right? So this is called as protected. Got it? If it is the first case, okay, that, yeah, I will wait in my lane. If I don't see any vehicle from the other side, I'll make the left turn. Okay, whether their signal is green or red, I don't mind. This is permitted. Got permitted? This is what? Permitted. Protected is their signal is green, I cannot do anything. Whether there is a vehicle or not a vehicle, doesn't matter. I'll go by the signal. This is protected. Okay, so for all protected cases, according to their study, the factor is 1.0. So, like I said, this is our case, right? You will not find any permitted left turns. Okay, maybe very rare. Okay, clear? Okay. Now let's say after you multiply with the factor, so you have the left turning movement, you multiply with the factor of left turning, it becomes, what was this? Television and what? Through vehicle limits. Okay, through vehicle limits. And through means what? Straight. Okay, so you converted it to straight. Okay, and again, if you have right turning, take it, multiply with the factor, you convert it to straight. So everything is now straight. Okay, all vehicles are in straight units, through units. Okay, if I want to add them together, I can, because they are same thing. Okay, if I want to compare between them, possible. If I want to take an average, possible. Add all of them, divide by number of things, no problem. Got it? Okay, so after conversion, all this is possible. Before conversion, not possible. Okay? Okay, now let's say we didn't have the table which they gave us. There was no table for the factor. I don't have the factors. Okay? We can calculate the factor ourselves by doing a short study. This is what they are showing here. It's a very, very short study. Okay? So for example, you are at a signal. The signal has two lanes. One of the approach of the signal has two lanes. Okay? I'm explaining the example which they have given, but you can apply it to anything. You have two lanes. One lane is for through only. The other lane is shared. You can go straight or you can take left. Okay? One is only through, the other one is straight and left both. Okay? Signal becomes green. I have a queue here, I have a queue here. These people are going here straight. These people, some of them left, some of them. I observe both the queues for X number of seconds. My time is X seconds. Okay? It could be the number of the green. Let's say green was for X seconds. Okay? Okay, so I observe it for X seconds. In these X number of seconds, I saw the through lane has passed 20 vehicles. In the through lane, the number of vehicles passes 20. Okay, so what is the rate here? 20 upon X, right? The rate is 20 upon X. In the other lane, I remember the other lane is straight and left both. Okay, so in the same amount of time, X seconds, in this lane, we saw 10 vehicles straight and 5 left. Okay, 10 straight and 5 left. So what is the rate here in this lane? 10 straight, 5 left. How many? Can I do 15? Why not?
Not straight.
Huh?
Not straight.
Because all of them are not straight. You cannot combine them. You cannot combine 10 of the straight with 5 of left. They are two different. Okay. So if I'm going to write the rate for the other lane, I will write it like this. I cannot add 10 and 5 together because they are in different directions. Okay. To add them, I must multiply with the factor of left turning, right? Got
Now we
it?
can add them.
Huh?
Now we can add them after multiply by
After.
factor.
Okay. So what is my factor here? How much? X will cancel out because it's both sides. So just doing 20 equals 10 plus 5 ELT. What is ELT?
Two.
2. Okay. So this is how you can calculate the factor for left turning for any situation. For any situation. Okay. Just need to compare the vehicles of one direction with the other direction. That's it. Clear? Okay. So, but the only condition is if you are comparing between two queues, these queues should be continuous. Okay. In one lane, 20 vehicles are going continuously, but in this lane I have only 2 vehicles. So the first 2 vehicles pass, the next one is coming after 15 seconds. You cannot add them now. There's already a gap. Okay. So if you want to compare between 2 lanes, these 2 lanes should have continuous flow. Okay. There's a gap. The gap should not be included, right? Clear or not? Clear? Okay. Let us do another example. We have total volume of 1350. In that we have 8% left turning vehicles. For these left turning vehicles, the factor is already given, 2.7. Okay. What is the total through vehicle unit volume? Okay. Right now they do not do any conversion. So they just are giving me number 1350, which is total. Okay. Out of this 1350, 8% is left turning. Okay. And the left turning have the factor of 2.7. So what is the total of through vehicles? Okay. First of all, I should find out how many are my left turning, right?
So 8 over 100 times
1350. Yes, what did you say? 8 over?
8 over 100.
8 over 100. So this equals to what?
108.
108. I need to convert them into through vehicles, right? They are left turning, I want to convert them through vehicles.
We multiply by 2.7.
We multiply by 2.7. How many?
291.6.
So 292. Okay. So out of 1350, 8% were left turning. The remaining are straight. I just add them, right? No conversion. I just add them with this 292. Okay. So why 92? Because 8% was left turning. So remaining is 92%, right? Okay, how much is this?
One, five, three,
3,
four.
4. So 1350 was the wrong number because you cannot add 108 with the straight. 108 were left turning, right? So they added them, they did wrong. Got wrong? Okay? The correct number is 1534 and we will call it through vehicle units. They are now through vehicle units. Okay? This 1534 is straight. All of them are straight. Clear? Okay. The next thing we need to do is decide on the critical. So once you have multiplied with the factors, now all volumes are in the same units, you can compare it and then decide about your critical volume or the critical gain. Okay. So for a signal, this phasing plan is given. Okay. Now this diagram is called as a ring diagram. Okay, it's a ring diagram. So you can see different movements are shown, and which phase has the movement is also shown. So A1 has two movements, right? Left and this. A2 has what? The straight and the other left. A3 has what? Two straights. Okay. B has what? Two straights in the other direction. Not so. Okay. And then you see some arrows are dotted. Dotted means it's permitted. Dotted means it is permitted. What was the meaning of permitted? What is the difference between permitted and protected? Yes.
So permitted that you have to stop no matter what.
No. Permitted is that you will move on chance from the signal. Permitted is you will move on chance from the signal. Okay. And protected means you have to wait for the signal. Clear? Okay. For each movement, they have given me the volume. They have given me the volume for each movement. Okay. Can I compare between the volumes? I have to pick one out of the two movements as my critical movement, right? Can I compare between them? Can I compare between two values? To do the comparison, I must do what?
Multiply with the factor.
Multiply by the factor, right? Okay. So this is already done. These movements, all of them are in through vehicle units. So whatever factor was to be multiplied, already multiplied. Clear? I don't need to do any multiplication. It's already done. I will just take and compare and take. Okay. Now if you look at phase B, the problem is very simple. I have 300 on one side, 280 on the other side. Which one will you pick? Maximum, right? I will pick 300 from here. Clear? Okay. Now look at phase A1, 150 and 250. Which one? Which one? 150 or 250? For A1. Two movements, right? One movement has 150, the other one has 250. Which one would you pick? 250. But is 250 in A1? No, it's continuous, right? It's continuing in the other phase. So I cannot say 250 is in A1. 250 is in A1 and A2 both. Got my point? Okay. A2, 600 and 250. Both are in the same phase, right? Can I pick one of them? No. Because this one is continuing and this one is continuing from the previous phase. Okay. So you can see here there is a mixture. In this case, in the upper part, there is a mixture. One movement starts and does not end in the same phase. It continues in the other phase. So I am not sure, okay, which value to take. Okay, these are called as overlapping phases, and in this condition, we look at the sequence. Look at the sequence. What are the sequence? The movements which have to happen one after the other. Sequence means the movements which have to happen one after the other. Look at the sequence on your left hand side. Straight and left, right? Left and straight. Can they happen together? Can these two happen together? No, right? So this is the sequence now. Got my point? Sequence means they have to happen one after the other in order. If they happen together, there will be a crash. Okay? So if you look at the left hand side, there is a sequence. The right hand side, same sequence, right? Okay? Clear? So I'll pick the sequence. Okay? I pick the volume from the sequence. Okay? So the first sequence on your left hand side, 150 plus 600, right? Total 750. Okay? If you look at sequence on your right hand side, 250 plus 550. Total 800. Which one is higher? 800. Okay? So for designing our signal, I'll pick this sequence, not this one. Clear? Clear? Okay. So my total volume is 300 from here and 800 from here. Total is clear? Okay. But you have to keep in mind they already multiplied with the factors. I'm doing this after multiplying with the factors. Okay. How to calculate the cycle length? This is how we calculate the cycle length. Okay. This is how we calculate the cycle. Okay. So we need what? We need n, number of phases. We need n, which is number of phases. How many phases you see here? Huh? Huh? How to?
4.
4. A1, A2, A3, 4, and B 4. Okay. What did it say 2?
And B.
No. A has 3 phases, right? We are taking the sequence just for the sake of taking the volume. Number of phases is 4. Okay. And then I need the total volume as well. My total volume is 1100. Got it? This is my VC. So now we come here. What is my cycle length? Everything else is given in this paragraph. So what is my cycle length? Tell me.
Now you want 0.
How much?
Now you want 0.
How? What do you do?
Also for the ratio, we take which number
Which ratio?
for the VC?
V by C is 0.9. Let's put it directly 0.9. V by C. VC is 1100. VC is my volume. V by C is 0.9. Yes,
21.5.
I'll kill you. I'll throw your phone. Which phone is this? It is iPhone or what? iPhone?
Same.
Your iPhone is better. Yes, you tell me. He has tablet. You doing what is tablet, right? You're doing it on this. Alright. See? What did you do? Show me. Four into TL last time. 4 into plus. 4 into 3, sorry. Last time. It's n into TL, right? N is 4. Where is TL? It's given. How much now? 4 multiplied by 3. 4 is number of phases. TL is last time. 3. How much now?
63.7.
63.7. Okay, my cycle length is 63.7 and we can round it up Okay, we can round it up. Okay, so we rounded up to the nearest 5 or nearest 10 seconds. Okay, so we will round it up to nearest 5 seconds in this case. But if somebody takes 70, no problem. What you need is 63 point something, right? You can make it 65, 70, no problem. Okay, but you cannot make it 60. It will be less. I cannot reduce it. You have to increase it. Okay, the second step after this is we find out the total green time. This is my total time. Now I'll find out total green time. Total green time means you will subtract the lost time. Okay, subtract the lost time. So my total time, sorry, I made it 70, 65. Just to be same with the other sections. Total green time. Total green time will be the cycle length after rounding up minus the lost time. Every phase has a lost time of 3. And how many phases we have? 4. Okay, so 3 into 4. How much? Okay, I need to divide this time into 4 phases. I need to divide this time into 4 phases. Okay, so I'll pick this from here. And put it here. Okay, the time should be divided according to the flow I have. Okay, for example, phase B, it had 2 values, right? I picked which one? Here. Okay, now I will use the ratio approach. Okay, my total time is 53 seconds. My total time is 53 seconds. My total volume is how much? 1001. Okay, so this ratio should be equal to the time of B upon volume of B. Time of B I want, volume of B I know 300. So this is how much now? Just 53 upon 1100 multiplied by 300. 14.4. Okay, for green time we can keep them as it is. No need to round up and round down anything. Okay, just whatever the value is. Okay, now I will go to the next phase, which is A3. Okay, I'll do the same thing with A3 as well. So total time, total volume, A3 time upon A3 volume. A3 volume was 550. Remember, I was taking it from here, right? This sequence. Okay, so in this sequence, A3 has 550. How much is this? Clear up till now? Any questions? Clear? Okay. Now the remaining thing is A1 and A2. Now problem with A1 and A2, I took this sequence, and this sequence A1 and A2 have the same movement. It's not divided. So I cannot say 250 for A1 and A2 both. There is no value for A1 and A2, separate values. I have only one value which is applied to both. Okay, so here it cannot work. Here the sequence cannot work. Now I am forced to go to the other side. Whatever I could have done from this side, I did. Now I am forced to go to the other side because there is no other movement which can give me this time. So I'm forced to go to the other side. Okay. Now if I go to the other side, which approach I was using? The ratio approach, right? Ratio approach was what? Total time upon total volume equals time upon volume, right? So if you take time and volume from here, total should also be from here, right? Total should also be from this side. Okay. So first of all, I will calculate the total time of this side, which is G A1, A2, A3, the total time of this side. Okay. So total green time was 53 seconds, remember? Out of that, B has a time of 14.4, right? So the remaining is A1, A2, A3, right? How much is this? 53 minus 14.4. How much?
Say it's 0.6.
38.6. This is my total time. Okay. And what is the total volume? This sequence, right? I have to go around this sequence, right? The sequence is not giving me anything now. So this sequence, okay, 150 plus 600, total is 750, right? So to calculate A1, now we'll use the time and the volume from this sequence. Okay, total time 38.6, total volume 750. I want time of A1 divided by volume of A1 from this sequence, which is 150. How much? 7.7. Okay, now the only remaining thing is A2, right? A2. Now I know total time was 53. Out of 53, B is this one, A3 is this one, A1 is this one. Okay, so how much is A2 now? How much? 4. Clear? So first of all, there were phases given, movements given. I picked the movements which are heavier and took the total volume as my critical volume. Then I calculated cycle length. Okay, from cycle length I calculated the total green time, subtracting the lost time, and then I divided the total green time into different phases using the ratio of their volume. Clear? Any questions? Okay, thank you.